Welcome everyone to our Spring 2022 IONiC VIPEr nanoCHAT YouTube video series. NanoChats are short videos where members of the community come together to engage in the critically reflective teaching practice of sharing our experiences with our peers. I'm Joanne Stewart, a chem prof from Hope College in Michigan, and I'll be the host for this episode. As many of you know, all IONiC VIPEr activities must be spelled with symbols from the periodic table. So this semester, this chat, or carbon, hydrogen, astatine, is called NeWBiEs, neon, tungsten, bismuth, einsteinium. And we will be capturing what it's like to teach inorganic chemistry for the first time, in real time, week by week. We'll be hearing from two IONiC members from the US Naval Academy Chemistry Department, who will now introduce themselves.
Hi, I'm Assistant Professor Wes Farrell. I'm in my fourth year here at the Naval Academy. I do research in organometallic chemistry mainly, looking at vanadium-mediated olefin metathesis and a lot of applications with polymer chemistry, and also getting now into doing Rath polymerization with applications in energetic materials. I've taught the plebe course here, which is our freshman chemistry series, and I've also taught our integrated lab 4 program, which is a combination of both physical and inorganic chemistry labs.
I'm Shirley Lynn at the Naval Academy. I came in 2002. I'm also an organometallic chemist, but this is my first time teaching inorganic chemistry because I have been in the past in the organic sequence that is a sophomore level 2-semester sequence and the accompanying integrated lab. I am an IONiC member from 2012, the very first big workshop at UNC Chapel Hill, and I've been involved ever since and just love this community. So it's a real pleasure to be able to do this series.
Okay, so thank you both very much. Could you both start off by describing the type of inorganic lecture course you're teaching?
Yes, this is going to be a lecture-based course. There's 2 sections. Shirley and I will each take one of them with a total of about 35 students. And they're all junior chemistry majors. It's a 4-credit course. So we're going to meet for 4 hours a week for 16 weeks. We're using the Weller's 7th edition textbook and some augmentation from the Wikibook online. Our students have already taken 2 semesters of general chemistry, 2 semesters of organic chemistry, biochemistry, thermodynamics, and kinetics. They've also taken 3 semesters of our integrated lab course. They're going to be taking this course along with quantum mechanics and also the last integrated lab in that sequence.
And Shirley, do you have anything to add to that?
I was just going to say that it's kind of at the very end of the foundation level course series in the major, and the senior year, the first year, is all dedicated to research and electives.
All right, can you tell us a little bit about the prep you've been able to do for the course so far? And we all know that undergrad inorganic chemistry is slightly different at every single institution in the country. And I'm just wondering, are there certain expectations at Navy? Where have you started? Have you had any materials sort of provided for you yet? So what's the plan so far?
I'll go ahead and start. So despite being a very seasoned faculty member, I've found the scope of the syllabus that we use for this course really challenging because of the breadth. And having been with IONiC for such a long time, I've heard many IONiC members talk about this, and I was always attentive, but now I'm getting to live that breadth, right? And just the sheer amount of material is pretty daunting. And we're really glad to have 4 credits to try to touch on everything, but we are still, of course, just scraping the surface on many of the topics. So one of the things that I'm struggling with right now is just looking at chapter 1. And chapter 1 is like this beast of a chapter that starts with quantum and goes through orbitals and then goes to, to periodic properties. It just seems like it doesn't end. And this is a little different for me, having taught organic so many times. I mean, organic as a traditional sequence, in the chemistry major is very well established. And I see the logical flow. I'm trying to find the logical flow in the course for inorganic. So that's something I love as we continue with the nanoCHAT NeWBiEs series, to just hear from all of our hosts and different folks about.
Yeah, sometimes we call it, trying to find the story. You need the narrative, you need the story, and that is really challenging. Wes?
Yeah, I share a lot of Shirley's concerns with the lack of flow within the course. And it is very broad. And for that reason, I've kind of decided to go with the guided notes approach, which traditionally I do not use. I'm very traditional in that way. I like to use the Blackboard and have minimal materials that I hand out. But for this course, I've decided to do that just because it's so broad and there's so much that it's even more just for me to make sure I'm keeping on pace and not skipping over anything or doing anything out of order. Because I want to make sure I deliver this material in a way that makes sense for the students and not just a way that makes sense for me. Hopefully, though, as I grow in this course and become a little bit more seasoned, I can go back to a way that makes more sense for my personal teaching style. But I think for this year, that's going to make things a little bit easier. And it also goes with a lot of the ways that people have taught this course in the past in our department. That's the typical way that they've done it. So that's a way that I'm trying to overcome this daunting aspect of just the breadth and depth of the material.
Yeah, I think that as there are some learning objects on VIPEr that talk about how to get started in the course, and there are also some sort of assessing prior knowledge quizzes and those kinds of things. And I've found that there are times when it sort of feels like the students remember nothing from their previous chemistry courses. And I know that's not the case, but sometimes it does feel that way. And so I sometimes look for creative ways to tap into that prior knowledge or activate that prior knowledge. And so, for example, one of the things that I've done is I'll start the course with just asking students, write down, and I do this usually in small groups to get them to talk to each other, just write down everything that you know about orbitals, just words, terms, etc. And they come up with these long lists. And it's really helpful in that as we then discuss and work through what is it they need to know about orbitals for inorganic chemistry, we find that the students list a lot of words, some of the things they remember, some of them, they're just like, yeah, I wrote down this word, but I have no idea what it really means. I just remember it was some word having to do with orbitals. So it kind of puts down a basis where they sort of can acknowledge to themselves they do remember something, because of course their gut reactions to say, oh no, I don't remember any of that stuff, but they kind of can say, yeah, I do remember something, and it gives them me a way to assess prior knowledge and sort of know where that group of students happens to be in that course as a jumping off point for talking about orbitals.
So as part of getting ready to teach this semester, Wes and I are working very closely together. And one of the things we created was a shared Google Sheet that had our syllabus in it. And then we looked up VIPEr LOs that would map onto the topic. So, we would have like this resource as the semester continued. And I love what you just said, Joanne, about tapping to prior knowledge. And one of the activities I'm going to use in chapter 1 is the one on orbitals that Hillary Epley and Maggie Gesselbrock had created years ago. That's on there. And it's, I think, even called orbitals. And so I'm excited to see what the students come up with. And I plan to put them in small groups and let them talk to each other about it and make their lists, and then we'll all report back out and then go from there.
Wes, do you want to add anything about getting started on the beginning of the class?
Yeah, I think one thing Shirley and I have talked about a fair amount is we want to try to introduce this course as a bit of a culmination of everything they've seen already. As Shirley said, after this, they're kind of done with their formal coursework, and then they're going to go into a research lab for their final year. So this is the last course they're taking along with quantum. So we want to kind of show how it brings everything together. And one of the ways we're going to do this is also another activity we took from VIPEr, is we're just going to ask them what they think inorganic chemistry is. And I've actually already done that through a Google form. I've gotten some responses. And a lot of them are just saying it's the chemistry of everything except carbon, a lot of the things you might expect. But then what we're going to do is go through the current issue of Inorganic Chemistry, the journal, and just go through that table of contents and just look at the titles and abstracts and kind of demonstrate that inorganic chemistry, while it is this set course in the way that we teach it, it really brings in a lot of different aspects. So we'll see how it affects polymer chemistry, which is really near and dear to my heart, and organic chemistry with catalysis, things like quantum dots, metal organic frameworks, and I can list 1,000 things now. but just really show them that this is going to bring together a lot of what they've seen before. So while it may seem like it's its own standalone course, we want them to see how these areas of chemistry all really work together.
Yeah, it's fun. I know that those like titles of papers can be a little bit intimidating to students at first, but they're actually pretty good at sort of being able to pull out of that title what the area of chemistry or the emphasis is. And so that sounds like a lot of fun. I think Shirley had mentioned before about the breadth of the course. And I know one thing that I do is with respect to all those topics that you maybe can't squeeze into one semester. So how much organometallics are you going to do? Can you do, how much will you do with materials? How much bioinorganic can you do, et cetera? And one thing that I found helpful is, so for example, with bioinorganic chemistry, when I first started, I would teach just a little bit about an enzyme or two. And I was always just not happy with that because I didn't feel like the students got any concept of what bioinorganic was. But now working with IONiC bioinorganic chemists, instead my approach is, all right, here's the 3 things I want you to know about topic X. And when I can do that, it's a lot of fun. If I can't come up with, here's the 3 things you need to know about topic X, then I might consider just simply leaving that topic out of the course. So those are really hard decisions that each instructor really needs to make for themselves.
Well, we're really excited to just go on this journey and to be documenting it through the nanoCHAT series. And I think viewers can expect for us to, come each week and, be a little shell-shocked, be a little bit, stressed out, and it's all going to be out there and visible and hopefully engenders a lot of great conversations about what it's like to teach inorganic.
Yeah, so just to provide a little more information about that, this is an introduction to what's going to be happening this semester, and many of the subsequent chats will be about specific inorganic topics. So I'm really looking forward to that. And each one will be hosted by a different person from the IONiC community. So I want to thank you for this great conversation, and thanks to all who watched this video. And I ask you, please feel free to comment about this nanoCHAT newbie series in the IONiC Discord, which is called the VIPEr Pit. In our next video, we'll find out how the first week of class went. So thanks, everyone.
Thanks, Joanne.
Thank you.